In this episode, we are moving from the more staged and linear view of system development into approaches that were shaped by a faster, more connected, and more changeable technology environment. Agile, DevOps, and other modern system development lifecycle (SDLC) approaches grew out of a simple reality. Many organizations could no longer afford to wait long periods of time before learning whether a system actually met business needs. Markets changed quickly, user expectations changed quickly, and technology itself changed quickly, which meant teams needed ways to learn, adjust, and deliver value more often without losing control. For a beginner, this topic matters because modern development is not just about speed or trendy vocabulary. It is about how organizations plan, build, test, release, and improve systems in shorter cycles while still protecting quality, security, and business alignment. When people misunderstand these approaches, they often assume modern means informal or uncontrolled, but the real goal is more disciplined learning and faster response, not less responsibility. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A useful place to begin is with the problem these approaches were trying to solve. In more traditional development environments, requirements might be gathered early, approved in detail, and treated as mostly stable for a long stretch of work. That can work well when the business knows exactly what it needs and when the environment is unlikely to change much during the project. The difficulty appears when users are still learning what they need, when competitive pressure forces rapid updates, or when technical risks become clearer only after teams start building and testing. In those conditions, waiting until late in the process to get real feedback can create expensive rework and deep frustration. Modern approaches emerged because organizations needed a way to shorten the distance between idea, development, user input, and improvement. Instead of assuming the full answer was already known, teams started treating development as a process of learning in smaller pieces while still moving toward a larger business goal. Agile is one of the most widely recognized of these modern approaches, and the easiest way to understand it is as a mindset built around iterative work, close collaboration, and the willingness to adjust based on feedback. Rather than trying to define every detail of a final system up front, Agile teams usually break work into smaller units that can be planned, built, reviewed, and refined over repeated cycles. This helps the organization deliver useful pieces earlier and discover misunderstandings sooner. For a beginner, the key idea is that Agile does not reject planning. It changes the way planning is done by treating plans as important but revisable rather than permanent and untouchable. The team still needs priorities, defined goals, accountability, and quality expectations, but it accepts that learning will happen during the work and that the solution may improve through repeated review. That makes Agile especially useful when requirements are evolving or when user feedback is essential to building the right solution rather than simply building a technically complete one. One of the strengths of Agile is that it encourages delivery in smaller increments instead of holding all value until a large final release. A team may focus on a limited group of features, complete them to a usable state, gather feedback, and then adjust what comes next based on what it learned. This can reduce the risk of spending months building something that looks impressive on paper but misses what users actually need in practice. It also makes progress more visible because stakeholders can see real outcomes instead of only hearing status reports about how much work remains. At the same time, this smaller cycle model requires discipline and prioritization. Organizations need a way to decide which work matters most, which improvements can wait, and how short-term delivery connects to a broader product direction. Without that discipline, teams can become busy without building lasting value. Agile works best when small increments are still guided by a clear purpose, not when development simply becomes a stream of disconnected changes made in response to whoever spoke most recently. Requirements are handled differently in Agile than in a heavily front-loaded model. And that difference is one reason modern SDLC approaches sometimes feel unfamiliar to newcomers. In a traditional environment, requirements may be treated as a large body of detail that must be finalized before extensive development begins. In Agile, requirements are often expressed in a more flexible and prioritized way so they can be refined as the team learns more about the work, the users, and the operating conditions. That does not mean requirements are vague or optional. It means they are managed as living guidance that becomes more detailed as implementation approaches. This gives the organization room to respond when users discover new needs, when earlier assumptions prove incomplete, or when business priorities change midstream. For a beginner, the important lesson is that modern approaches still need clarity about purpose, scope, and expected value. The difference is that they accept the fact that understanding grows over time, and they create a process that can absorb that learning without waiting until the very end to discover whether the system is truly useful. Team structure and collaboration also look different in modern approaches because the work depends heavily on quick communication across roles that were once kept farther apart. Instead of passing work through long handoffs from business analysis to development to testing to operations, modern teams often try to bring those perspectives closer together throughout the life cycle. Business representatives help shape priorities, developers build and refine the solution, testers evaluate quality continuously, and operational concerns are considered earlier rather than after the system is already finished. This can reduce misunderstanding because people are not waiting until the end of the project to discover what another group expected all along. It also means responsibility becomes more shared. Teams do not get to say the code is complete, so the rest is someone else's problem. For a beginner, this is one of the central cultural shifts of modern SDLC thinking. The goal is not just faster work. The goal is fewer blind spots created by separation, delay, and communication that happens too late to be useful. Even with these strengths, Agile is often misunderstood, and those misunderstandings can create as much trouble as the older problems it was meant to solve. One common misconception is that Agile means no documentation, no long-term thinking, and no formal accountability. In reality, responsible Agile teams still document important decisions, still plan beyond the current cycle, and still maintain clear roles and controls. Another misconception is that Agile means endless change with no stable target. Good Agile practice allows adaptation, but it still depends on priorities, governance, and an agreed direction for the product or service. There is also a mistaken belief that moving quickly automatically makes a team agile. Speed without clarity often just creates hurried confusion. Beginners should understand that Agile is not permission to be disorganized. It is a disciplined way of working in small, reviewable increments while staying connected to user needs, business goals, and quality expectations. Without that discipline, a team can use Agile language while operating in a way that is neither modern nor well-controlled. DevOps adds another important layer to modern development by focusing on the relationship between creating systems and running them reliably in real environments. The name joins development and operations because the core idea is that those two worlds should not behave like separate kingdoms with different goals and limited communication. In older environments, developers might focus heavily on producing new features while operations teams focused on keeping systems stable, sometimes creating tension because rapid change and stable service can pull in opposite directions. DevOps tries to reduce that divide by encouraging shared responsibility for the full path from development through release and into operational support. This matters because a system is not truly successful when it merely passes internal testing. It has to function dependably under real conditions, with monitoring, recovery, support, and maintainability all taken seriously. For a beginner, DevOps is best understood not as a tool set, but as a way of aligning people, process, and technology so the organization can deliver change more reliably and recover more quickly when problems appear. Automation is one of the practical enablers of DevOps, but it should be understood as a means rather than as the goal. Modern teams often automate repetitive activities such as building software, running tests, checking for basic errors, packaging releases, and moving approved changes through controlled environments. The benefit is not simply convenience. Automation can reduce manual mistakes, increase consistency, and shorten the time between making a change and learning whether that change behaves as expected. It also makes frequent delivery more realistic because teams are not depending on the same long sequence of manual steps every time they want to release an improvement. Still, automation is only helpful when it is well designed and governed. Bad automation can spread defects quickly, bypass needed review, or create a false sense of confidence if nobody is checking whether the automated process itself is reliable. That is why beginners should think of automation as disciplined repetition. It helps organizations deliver and test more often, but it does not remove the need for good judgment, approval structures, and visible accountability. Quality in modern SDLC approaches is handled very differently from the idea that testing waits patiently until development is almost finished. In Agile and DevOps-minded environments, quality activities are pushed much earlier and repeated much more often. Teams try to find problems sooner because a defect discovered close to the moment it was introduced is usually easier and less costly to correct than one discovered after many other changes have piled on top of it. This leads to a more continuous view of testing, review, and validation. It also changes the mindset around defects, because the goal is not to gather a large collection of surprises near release, but to reduce uncertainty steadily throughout development. Monitoring after release becomes part of the quality picture as well, because the organization wants to know how the system behaves under real user activity, not just in controlled project conditions. For a beginner, the major lesson is that modern quality management is not lighter than traditional quality discipline. In many ways, it is more constant, because the team is expected to think about reliability, usability, and correctness all the way through the work. Security must also be part of this continuous mindset, because modern delivery approaches can create speed that becomes dangerous if protection is treated as something to think about after features are complete. In a well-run modern environment, security considerations appear early in design discussions, in code review expectations, in access control decisions, in testing, and in release practices. The organization does not wait until the last moment to ask whether sensitive data is protected, whether permissions are appropriate, or whether the new change could weaken controls. This is especially important because faster release cycles can multiply the damage of weak discipline if issues are pushed into production repeatedly and at speed. For audit and governance purposes, this means modern approaches should still show evidence of review, approval, control design, and accountability even when changes move more frequently. Beginners should remember that faster development does not reduce the importance of control. It increases the importance of building control into everyday work, because there may be far less time to correct weak thinking after the system is already moving through rapid release cycles. Governance remains essential in modern approaches, even though it may look different from the stage-by-stage approvals associated with a more traditional model. Instead of waiting for one large sign-off after a long development phase, organizations may govern through approved backlogs, defined release policies, automated control checks, role-based approvals, change thresholds, and frequent review of metrics, incidents, and priorities. What matters is not whether the governance looks old or new. What matters is whether management can explain how work is prioritized, how risks are accepted, how changes are reviewed, how production access is controlled, and how failures are detected and addressed. This is a key point for beginners because there is a common misunderstanding that modern development somehow eliminates the need for formal oversight. It does not. It often spreads oversight across the life cycle in smaller but more frequent forms. From an audit perspective, the question is still whether the organization is managing change responsibly. The evidence may come from different places, but the need for control, traceability, and accountable decision-making does not disappear. Many organizations do not operate with a pure version of one model, which is why hybrid approaches are so common in real life. A company may use agile methods for application development, DevOps practices for testing and release automation, and still retain traditional governance gates for architecture review, security approval, vendor oversight, or major production cutovers. This kind of blending is often practical because different systems carry different levels of business risk, regulatory sensitivity, and operational complexity. A public-facing website with frequent updates may benefit from rapid cycles and close monitoring, while a core financial platform may still require more formal approvals and documentation before major change is introduced. Modern SDLC thinking does not demand that every system be treated the same way. Instead, it encourages the organization to match its delivery approach to the nature of the work while preserving control appropriate to the level of risk. For a beginner, this is reassuring because it shows that modernization is not about throwing away structure. It is about applying structure in forms that suit the pace and uncertainty of the environment. There are several misconceptions about Agile, DevOps, and modern SDLC approaches that are worth clearing away because they can distort both management decisions and audit conclusions. One is the belief that modern approaches are always better than traditional ones, regardless of context. In reality, they are often better suited to environments where requirements evolve, delivery needs to happen more frequently, and learning through iteration is valuable, but they are not automatic solutions to every project problem. Another misconception is that documentation and control are enemies of speed. Poorly designed bureaucracy can slow useful work, but thoughtful documentation and well-placed control often prevent the much greater delays caused by defects, outages, and rework. A third misconception is that DevOps is mainly a technology platform rather than a shared operating model for delivery and support. Beginners should keep the bigger picture in view. Modern approaches succeed when they improve responsiveness without sacrificing quality, accountability, and trust. When those elements are missing, the language may sound modern while the underlying practice remains weak. The central picture should feel much more practical and balanced. Agile, DevOps, and other modern SDLC approaches were created to help organizations respond to changing business needs, deliver useful improvements sooner, learn through feedback, and operate systems with closer connection between development and real-world performance. They matter because many organizations cannot wait for long, rigid delivery cycles before discovering whether their systems are helping or hindering the business. At the same time, modern does not mean careless, and fast does not mean uncontrolled. The strongest modern environments are the ones that combine short feedback cycles, collaboration, automation, quality discipline, security awareness, and governance that fits the pace of the work. If you keep that understanding in mind, this topic becomes much easier to follow. It stops sounding like a contest between old and new and starts looking like a question of how organizations can change systems responsibly in a world where both business expectations and technology conditions continue to move quickly.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.